This is my game Altered Sensorium. It's a fast-paced, weird-looking, and intense first-person shooter where you rearrange your fingers that I built entirely on my own with no game engine in C, just a couple of low-level dependencies, and since you probably remember it from when it looked like this, or this, and it's been a while since I've given an update on it, let me explain why I took a break from it, why I redesigned it, and how I got it to look and play like it does now. So when we left off last time, I had made a Quake/Doom-like game engine with a custom map editor for 2D level layouts, two different kinds of weird portals, fully 3D models, a bespoke lighting and shadow system, this fancy dither effect, and the ability to run around and shoot things while you're carrying this floating eye. There were a lot of good elements here, especially in the aesthetic I think, but I'd had a tough time with gameplay, trying out and scrapping a bunch of different small prototypes that I never really found too interesting, all the way from when the project was a software renderer up to it being fully 3D. So in order to not get totally burned out by trying idea after idea, I tried to put the project on the back burner for a little bit and looked for inspiration in other simple, straightforward, and intense first-person shooters like Devil Daggers and Post Void. Two super intense indie FPS games that have really deep gameplay from simple mechanics, and then I came back and asked myself where I wanted to take my game. So let me introduce you to the game design for Altered Sensorium. My initial thoughts were centered around one simple concept. What if you cut off your fingers and the core gameplay mechanic was rearranging and collecting fingers to create different weapons that affect game rules? The fingers could affect your stats, the way you shoot, things like that. This would of course mean getting rid of our friend the eye, but to be honest I could only really think of one game mechanic I wanted to use it for in a fast-paced shooter, and that was kind of already taken. Altered Sensorium is a medical term though for an altered level of consciousness, which I thought could map well onto the aesthetic that the engine was already able to deliver, and play well with the idea of removing your own fingers as a sort of coping mechanism for neurotrauma. So basically the game is that you cut your fingers off and plunge yourself into a sort of unreal mind prison where you shoot things with your reconfigurable finger guns to move through levels quickly. Also the whole time you are bleeding out and can only gain blood back by killing enemies, so you need to be quick and precise about things. Each level is a set of increasingly difficult rooms connected by portals and finished off with a boss fight, all of which you get to from a central hub level. And that's basically it. So the first thing that I designed for the new concept was a finger shop where I wanted the player to be able to hold their hand up in their face and buy, sell, and rearrange their fingers with the cursor. So I started by making a new hand model in Blender with a proper skeleton this time, and rewrote some bits of my model rendering code to support Blender's vertex groups so that I could render fingers individually even though they're part of the same model. I got the model rendering in-game with each finger being rendered with its own vertex group and using a different color, and computed view space bounding boxes around each finger so that the cursor could interact with them. Right now I just boost the bloom effect on them to make it clear when they're getting highlighted by the cursor. The system cursor is kind of immersion breaking though, so I wanted a custom cursor that matched the aesthetic of the game. So using the hand model mirrored and positioned differently, I added in this phantom hand which gets rendered in a different layer than the rest of the game, using an orthographic camera projection to avoid perspective distortion issues that would kind of otherwise make it uneven at the screen edges. But it's basically just a cheap way for me to avoid drawing the same 2D hand image as a sprite. The 3D model works pretty well though, and with the cursor moving around, I wanted to add the ability to click and drag the fingers to rearrange them, which kind of introduced a problem for me. If I grab this finger here in 2D space with the cursor position, then I move the mouse down here with the cursor, what's this vector in world space that I need to offset this 3D model of the finger by? The fingers aren't rendered in 2D, so this required some pretty fancy math, which, well, speaking of fancy math, this video is sponsored by Brilliant. Brilliant is a free and easy way to learn math, computer science, data analysis, and well, basically everything that I like to talk about on my channel. With a platform and lessons designed to be uniquely engaging and effective, Brilliant can help you build an understanding of important programming and math concepts from the ground up all the way from beginner to advanced. So whether you want to get started with algorithms and data structures or dust off some old math skills, Brilliant is a great way to build a daily learning habit interactively and at your own pace. Since what I do on my channel is so heavily math-based, if you've ever thought about doing something similar like making your own game engine or just toying around with shaders, I can highly recommend Brilliant's course on vectors as a good way to build the intuition and fundamentals needed to do what I do in my videos. So if any of that sounds like something for you, you can try out everything that Brilliant has to offer for free with a 30-day trial by going to brilliant.org/JDH or by clicking the first link in the description. You'll also get 20% off Brilliant's annual premium subscription, so don't hesitate to give it a try. And thanks again to Brilliant for sponsoring this video and for helping to keep my channel going. So after a big think and a couple of diagrams, the way that I ended up finding this offset in my mystery vector was by defining a plane that goes through the 3D center of each finger, which points in the same way as the camera, and then taking the camera ray from the screen pixel the cursor is at and finding out where it intersects with this plane. Then we have two different points on the same world space plane, so if we take this 3D distance, we can offset the finger's world position by that amount and make it match with the current cursor location. And this will seamlessly follow the camera around no matter how we turn. To smooth things out a little bit too, I added in some interpolation and an initial offset when the cursor grabs the finger so that you can grab it anywhere and it doesn't weirdly snap to the cursor position. So now the player can click and drag and move these fingers around and properly rearrange their hand. With the finger shop implemented, I decided that the finger shopping should happen during level and room transitions, so I took the infinite falling portal mechanic that I made in my last video and added some scrolling fractal noise in the background to make it look like the player is swimming or falling in blood, and then I threw in some scrolling flavor text on top of that. The text gets smoothly interpolated with text describing what each finger in the shop can do, which I think makes for a pretty immersive menu. With the ability to rearrange fingers in the shop totally done, I went back to the drawing board with shooting mechanics and ripped out the system that I had in my last video with different weapons, since the fingers will be replacing all of that and we don't need our trusty shotgun anymore. I also removed the pattern drawing reload system, which I really enjoyed, but I don't think it will play that nicely with more fast-paced gameplay, but I'm willing to add it back in if it seems like it might be the right fit later on. I experimented with a few different ways to do finger configuration and shooting, initially with this system where the player had 2 hands and 10 fingers to configure, where each finger configuration would make a unique weapon and hand shape like this, but a total of 256 possible weapon combinations, not to mention the different fingers that the player could use, seemed like it might be a little big of a design space, so for now I decided to go with the system where the player has 1 hand to configure and the thumb changes the current weapon type. Though I still like the idea of different finger configurations making different hand shapes, so that will probably return later on. With one hand though, if we start shooting, you can also see that I added new player projectiles into the game, which are these stretched cubes that have their tails animated with a noise effect and a whole lot of bloom on them. I tuned up the shooting a bit too with some lights and this contrast effect as we shoot, and you might notice that there's this juice in our arm. Well, that's the blood that leaks out that I mentioned earlier. I really wanted to focus in this game on using immersive UI elements where I could, like the finger shop, so instead of your typical health display as a number or bar on the screen, I decided to slap an entire smooth particle hydrodynamic simulation into the player's arm. The simulation itself is more or less standard stuff, which I'm not enough of an expert in to properly explain, but if you do want to learn how that works, I can highly recommend this video by Sebastian Log and this article, both of which I'll link in the video description. Basically though, it's a way to simulate fluids as a bunch of individual particles, each with forces like gravity, density, and viscosity affecting each particle. I started by implementing the simulation as a standalone program in C so I could play around with the parameters and get it properly optimized for use in the game, and then I brought it into the engine. To keep things contained, I take the player's current arm model position, create a subset of points from the on-screen vertices, and then create a convex hole around those points in order to contain the particles. And currently the whole simulation deal is on the CPU and is multi-threaded with OpenMP, but I might consider moving to a GPU-based simulation later on, especially if there are performance problems on slower machines, because it can get quite heavy sometimes. You can see though the individual particles in the debug visualizer here, but to render things in-game, the simulation particles get gathered up and sent off to the GPU so that the arm blood can be drawn in one of the post-processing steps, with a little added visual flair from some very light scrolling fractal noise. Currently, the particles don't really respond to relative player movement from gravity or camera rotation, but it's on my to-do list to get that implemented, and they do move around a bit anyway while the player is running. The final bit of hand-based gameplay that I got implemented was this main menu, which I made using the same basic in-game finger system that the shop uses. The menu has a start button for the pointer finger, a leaderboards button for the middle finger, which might change into something else if I don't end up implementing leaderboards. This options menu is accessible via the ring finger, and this just uses some standard text-based UI elements for configuration since I don't really think you want to be adjusting your field of view on a finger-based menu. And then we've got this about menu on the pinky and the thumb as the quit button. The menu is rendered directly in-game, so if we hit start, we go into our hub level. And on first glance, you probably think this looks pretty different from how things looked in my last video, so let's take a step back and I'll explain how I got the graphics to look this way. So the game used to look okay, I think, if a little bit dark, but it seemed like it was lacking in some finer aesthetic detail and depth, so the first thing I did was I added this fixed per pixel dither effect inspired by a demo of a game called Eclipsium. Basically, I boil everything in the game down to a 256 color palette after applying all lighting, and put it through some simple ordered dithering. The effect might be a little too subtle to even show up on YouTube, but it adds a pretty large degree of texture to everything on screen. In addition to the 256 color palette, at earlier stages in development I'd experimented a lot with varying degrees of palette restriction, like 8, 16, and 32 color palettes, and I liked a lot how these looked, but it seemed like it might be hard to make an entire game with these, so instead I decided to split the difference and I implemented an 8 color palette for each level that only gets applied to walls, floors, and ceilings. The colors are just up here in a little menu for the map editor and they get saved alongside each level. This will be used to give each level its sort of own unique color identity. The 8 color palette also leads into the low visual fidelity sort of vibe that I'm going for, which I think will help the player focus only on what's directly in front of them, and kind of add to the intensity of the game. To spice up the visuals even more, I added a dithered vignette effect with scrolling text around the edges of the screen, synced to a constant heartbeat sound to go in and out, again using some fractal noise to animate things. Not only does this give a little extra something to the visuals and frames the game nicely, but I can also use this text to show when the player takes damage, and to communicate things like when to exit a room. I'll probably also want the vignette to creep in and the heartbeat to get more intense as the player is closer to losing all of their blood. To round out the basic graphics effects, I also fixed up the bloom shader by replacing my old Gaussian blur with a really simple downscale and upscale blurring system, which also happened to be way faster than the old Gaussian blur. And generally I just cleaned up a bunch of small issues in the graphics, like with the world space pixelization effects to make sure that everything's aligned, and then making sure that decals and shadows are always properly pixel aligned with things. We can see all the shader tricks, effects, and fixes back in action on the hub level. The hub is how the player is going to select levels, kind of inspired by Quake 1's difficulty and episode select level. It's just an area where the player can move around and hop into different portals for different levels, each portal having its own unique color, and this text effect that shows which level it is when the player is close to it. Overall though, there's nothing special about it, and the hub is just a standard in-engine level with a few extra effects. The sectors and walls are marked as sky, which means that they get rendered using the sky effect, which is even more scrolling fractal noise fixed to the world space view direction this time, and it's used to give this red coloring effect. It also gets mixed with some more subtle scrolling text, which also serves as a description for each portal. Floor here too is just a regular old material with some scrolling text over it. And I also implemented this class of special entities in my level editor, which are these small cubes. Only visible in editor, but it's so we can have a spawn point here, some fill lights over here to make things more dramatic and clear to the player, and this special fade origin level center entity which just indicates the point for where the level fade effect to start and the general boundary for the hub level. The boundary effect also just uses a dither matrix pinned to each rendered pixel's world position to fade level geometry out smoothly into the sky. And the only other thing that you can see in the hub level is this wall, currently with a head on it. This is where I want the player's trophy collection to be as the levels are completed and the bosses are beaten. If we hop down into one of these level portals though, you can see this level text transition that I added, which just shows the name of the level in this stylized way before fading out and going into the finger shop before you start the level. I'm also using the same effect for room-to-room transitions when the player exits the room as a sort of way to punctuate each encounter and make this weird poem thing. Because instead of saying the level name again, each level uses a Markov chain-based text generator to make this sort of poem-like interlude between each room. Currently, the generator just uses a big corpus of Percy Shelley poems, which can give some pretty funny results right now, but each level will eventually have its own small corpus of theme poetry that it'll be able to pull from. The generator basically works by probabilistically predicting the next word in a text based on n previous words using a big dictionary that maps prefixes to lists of their possible suffixes and then picking things randomly. You can sort of visualize it as a sliding predictive window over the generated text, but I'll link to an article in the description about this algorithm as well if you're interested in learning more. Normally, I'd be pretty adverse to randomly generating lore text like this, but I think specifically in this situation, the random and nonsensical nature of the Markov chain text fits the vibe of the game pretty perfectly. I'll probably just need to fine-tune it a bit based on what I'm seeing now. Hopping out of our poem portal though, we can get to our first enemy encounter with these guys, the crawlers, who have gotten a significant upgrade since we saw them in the last update. I realized that in order to make a good 3D game, I should probably learn how to make proper 3D models, so the upgraded and animated hands are the first product of this. The hand model is more or less the same one that the player has, just using some different finger proportions, and I animated them with this reference video of my own hand walking. They basically just run around and try to hit the player. You can see as we shoot them that I added in a couple new particle effects too, like these sparks, which are just quads that get scaled and rotated according to their current direction and velocity, and these blood particles that come out of enemies which get similarly rotated and again use even more fractal noise for their shape. The blood particles also use this gore effect decal system that's been supported in the engine for a while, which can dynamically place decals wherever particles collide with level geometry, though with some significant upgrades from how things used to look. Initially, these decals were rendered with the same noise system as the particles, but I found that if the player was in one area for a while and there were a lot of these decals, doing the noise sampling and especially the discarding and the shaders that the particles used was getting really expensive. So instead, I made a system that on startup just renders 16 large and 16 small blood textures using this shader here, with the same noise rendering technique that the particles use, and then these are randomly applied alongside pixel snap rotation for each blood decal, so the effect is basically the same but a few thousand times less GPU expensive. And now we can have a bunch of hands that explode into blood. As we shoot them, you can see that I made a little death animation for all enemies by running an expanding 3D noise texture through them to make them disappear as they explode. All enemies also have this edge effect around them to make them stand out more, but I'm not entirely settled on how this looks yet. I kinda just think that gameplay wise it's a little necessary to make things clearer to the player. In our little fights with these hands, you can also see that movement got tuned up quite a bit from the last update. Generally, I didn't really like how light and bouncy the player movement felt, so I worked on making things feel much heavier and more impactful by making the camera movements and field of view changes happen faster, while adding movement combos for slide dashing, dash sliding, slide jumping, jump sliding, and generally just making the movement feel a lot better. Also now, if the look direction is offset from the slide direction when the player starts to slide, the camera gets tilted pretty dramatically, which I think makes sliding look a lot more fun and also adds some extra drama to the movement. In addition to these hands we've been fighting against though, I also designed some more enemies, taking inspiration from this book of art by German psychiatric hospital patients from 1922 called
BILDNEREI der Geisteskranken, ein Beitrag zur Psychologie und Psychopathologie der Gestaltung.
So first I came up with these guys. They're called Scions, based on a little sketch that I did of a head with legs. They run after the player and try to explode whenever they're near, dealing a lot of damage, but they can also be used strategically to explode other enemies if you shoot them at the right time. To animate them, I looked at this video of how to animate a spider and basically just followed the 8-leg pattern for a spider for their 6 legs, which I think makes for a pretty convincing running animation. After that, I added in our first flying enemy, internally just called the Big Mouth, which I think is pretty self-explanatory. They kind of just fly after the player and try to bite them. And then I modeled this half brain, half silt strider, almost walnut looking thing I call a mother. Mothers fly around pretty slowly, try to avoid getting too close to the player, and spew out these floating grain egg sacs which will explode if they get near you, or after some set time delay. Adding the egg sacs also revealed some performance issues in my engine, both in the game logic and renderer, since I hadn't really tried having this many entities in one area before. To combat the game logic performance hit, I decided for large group enemies like egg sacs to split their updates out so that each individual egg sac only gets updated every n frames with a delta time scaled by n instead of every frame, which helps out a lot with the physics performance and is basically unnoticeable in game. And then on the renderer side of things, I added a system where each batch of models that are rendered in game get auto-sorted according to which model they are, and then when 2 or more of the same model get rendered in the same batch, they're automatically instanced, which looks something like this in pseudocode. So basically, instead of using 100 draw calls to draw 100 egg sacs in the same area, we just use 1. To round out our current enemy roster, I also added these turrets, which are eyes that float around attached flesh lumps that can appear on walls, which shoot these rotating bright cube projectiles after the player. These were designed mostly before I decided how I wanted the graphics to look though, so them, their projectiles, and their particles will really need an update at some point. As for non-enemy entities, like you could see in the hub before, I also made these heads that you can shoot to collect in-game, which I figure will make pretty good currency for the shop and give the player another thing to focus on while in combat. So if we put everything together now with the graphics, the weapons, the movement, the shooting, the enemies, and the handgun, you can now go to the hub level, hop in a portal, and try to survive while shooting enemies and go from room to room with these text interludes when the exit opens up. Currently the rooms are laid out in a random order, but as I get more of a handle on the overarching progression through the game and through individual levels, I'm going to add more fine-grained control over in what order the rooms appear and with which enemies. This though is the game now. And while we can appreciate that there's finally a game to play, another reason why this video took so long is because when I came back to this project, I basically took a giant wrecking ball to the engine code. Starting with the biggest issue, which was that the engine used to use a binary level format. This was really easy to serialize and deserialize, but it was really rigid and required me to write manual upgrade functions for the format every single time I wanted to change or remove a field on a level component, which kind of happened all the time. This was obviously pretty silly and not optimal for development, so I took some time and cobbled together JSON support for my C utilities library so that I can use JSON as an in-development plain text map format. It's about 10 times bigger and 10 times slower than the binary maps, but for the sake of iteration speed, which is my primary focus right now, it's a whole lot better. An even bigger backend change than that though was that I upgraded my renderer to use a newer version of Sokal, the library that I use for cross-platform graphics, which finally had support for GPU storage buffers. I don't think I ever mentioned it in a video before, but in earlier versions of the renderer I was jamming all of the rendering data for each level object, like sides, sectors, and decals and entities, into these structs which would get packed into textures and unpacked using these unholy looking functions here. The system was kind of ridiculous and super bug prone when I was updating these unpacking functions, so I wanted to replace this with some storage buffers for arbitrary structured data. Only problem though was that storage buffers require OpenGL 4.3 and my lovely Mac that I develop on is stuck on OpenGL 4.1, and I'd been using some very OpenGL specific stuff to do stencil based portal rendering for the game. So at first I tried to rip out the entire OpenGL renderer and replace it with WebGPU, but after building some different implementations of WebGPU to varying degrees of success and wondering why there was so much overhead for the one that I could get working, I ended up just biting the bullet and making a real cross-platform renderer that could support both Metal, Apple's graphics API, and OpenGL for all other platforms. This did mean that I spent a lot of time messing around with coordinate systems trying to get this to work, but in the end I could get rid of these awful unpacking functions, and the whole portal renderer is just a lot less buggy now that I cleaned up the OpenGL specific stuff. And as an added bonus, the storage buffers are also what made the liquid ARM particles possible. As for other internal engine updates, I made the physics happen at a fixed rate of 240 updates per second, which makes things way more deterministic and will make it way easier for me to implement demo files at some point. And generally, I just removed a bunch of dead code from months of messing around with different concepts for the game. Everything's a lot more stable now, the editor doesn't crash nearly as much, and everything's a lot more concise now that I'm able to focus in on a single concept for the game. Still all beautiful, lovely, handcrafted C code though. And that's it for this update. The project sure has come a long way from its days as a software renderer tech demo, and next time I'll be adding even more to the game and fleshing it out. And Indie Game Marketing 101 would also tell me that I should have made a Steam page for this thing already so I could tell you to go wishlist it, but I haven't really gotten around to that yet, so just keep the name Altered Sensorium in your head in the meantime. My Patreon is back up and open to new signups now though, so thanks to everyone who's supporting me on there. You can sign up if you want to see the source code for this game, any of my older projects, or if you just want to support me. Though, fair warning about the source code for this, there are no Windows or Linux builds right now since my PC graphics card died and I'm waiting for a replacement for it. I'll get the builds up and running as soon as I get that though. Anyway, that's all for this update, so thanks for watching and see you next time.